I repeat one more time regarding this, okay? I believe you, understand the parallel axis theorem. The parallel axis theorem is basically I about any axis, okay? I O basically is equals to IG plus M B O. It is the basic of parallel axis theorem. It should always refer to the center of gravity IG. Okay, for this disc, the semicircular disc, if you look at the table provided to you, okay, you are given the I for this axis, that axis, and that axis. Okay, let's name this as A, B, and C. Okay, between these three axes, if you see, for this semicircular, the center of gravity is somewhere over there. Okay? If you learned stating before, the distance is basically is 4r over 3 pi from the base of the disc. So from the three axes A, B, and C, the only axis that pass through G is your B axis. That is the only axis that pass through G, because this is your G. The other two axes, C and A, does not pass through G. Okay, if we go back to the question, we are required to find IQQ, which is up there. Parallel to IQQ, okay, the pass G is this axis, IGQ. Okay, if you refer to this diagram, there is no formula for this IGQ, the I that pass through G. What we have is the one parallel to your axis pass through G, which is the A axis. This A axis is parallel to the G axis, the GQ axis. That is why we use this formula to get your IGQ. Using the parallel axis theorem, basically your IAA is equals to your IG plus MB squared. Okay, in our problem, that is this formula. IZ, that is your A. And same axis, okay? This and this is the same. Okay, so from this formula, we know IAA. This IAA or IZZ we know. So basically we know IAA. And the distance B also is known, which is 4r over 3 pi. So from here we get our IG. IG is equal to IAA minus the MB squared. This is what I do here. Then you get your IG. This is your IG. After you get your IG, the I passes through G, then only you use parallel axis theorem between Q and G. This is what I do down here. IQQ is IG plus MB squared. Okay, got it. Is it clear? Okay. No problem. Thank you. Okay. Another thing. Victoria just now. So chapter 9, example 6 from the set for the D. For this Del. Okay. Is it the same one, Del? Is it? Del? I know this is from who? There is Del. Okay. Okay. Thank you, Del. Victoria, you asked me a question just now. I lost it somewhere. 4.9 for the textbook. Farhan, 4.4. 4.4, where is 4.4? 4.4. 4.4. It says here 4.4. Which one is it? Okay, Farhan, 4.4, okay? Hold on. I try to find the question.
Sir,
Answer 4.14.
4.14, sir.
4 point?
14.
Okay, so I try to explain 4.4 first, okay?
Okay.
Okay. Okay, this is 4.4. Okay, this is not that difficult. Basically, you need to understand there are two two bodies that are moving. The first one is the bomb, okay, which is projectile motion. We are releasing the bomb with the initial velocity of 80 meters per second and the angle of 60. And then 5 seconds after the bomb is launched, after 5 seconds, the bomb is at A. Okay, the bomb reaches 600 meters in 5 seconds. The velocity VA and SA. At the same time, at the same instant, a fighter has been flying at a constant altitude, velocity 100 meters, acceleration 3 meters, determining acceleration of the bomb relative to the jet. Okay. Okay. So this is not difficult. What you need to do is, okay, first, yeah, you need to understand the system. Okay? The system explains, okay, what happened after 5 seconds. After 5 seconds, this bomb reaches point A. This is basically projectile motion. By using projectile analysis, okay, projectile analysis, which is in chapter, which chapter? I don't remember. Never mind. Okay, you need to find your VA and AA. So basically for this VA X is known. VAX is equals to UX, which is, this is your UX, 80 cos 60. VAY, you need to use the formula for projectile. Okay, you are given the time, so basically your VAY equals to UAY plus AYT. Agree? So your VAY should be U cos sine 60, okay, minus 9.81 times the t. Your t is 5 seconds. Okay, so you get your VA X and your VAY. Your U sine 60 is basically 80 sine 60. 80 sine 60 minus 9.81 times 5. Okay, this is your VAY. You get your VAX, you get your VAY. Okay, then you also need to find your A, acceleration at AA. So AA is quite straightforward. AAX equals to 0. AAY is equals to G. I lost it somewhere. Exercise, example, exercise 4.1. Sorry about this, guys. Okay. Okay, your AY is basically equals to G, which is 9.81. 9.81, pointing downwards. Okay? Once you get your AA and VA, Okay, you got your AALV, the rest is the same. Okay, you are given the velocity and acceleration of your aeroplane. Then the rest you do the same. Okay, acceleration of bomb relative to A. Basically, you are required to find A bomb relative to the jet. Basically, it's A B, okay, minus A jet. Right? A B is given. A jet, which is G 9.81. Then you get your ABG and your and that's it. Okay. Why they ask a very simple question? They didn't ask about the velocity, is it? I think the question should ask the VBJ as well. This one is more difficult. This is VB minus VJ. Okay? Because we need to calculate the V. VB, this is equals to VBJ is VBX plus VBY, minus VJ. Okay. Because you already have your VAX and VBAY, this is your V bomb. This is V bomb, VBX, VBY. Am I clear about this? Is it clear, Farhan? Okay. Just now, Kapil, this question, Kapil. 4.14, is it? Kapil, this question,
4.14, sir.
4.14. Okay, the figures, let me read the question first. Before I share with you. Okay, 4.14. I cannot share. I somehow cannot share the content. I don't know why. Yeah. I got problem with the software. Okay, 4.14. Okay, I just read it for a while and then I start to explain. I found this direct software. Never mind. Okay, the figure shows two boats, A and B. The two boats start simultaneously from O in their respective direction. Okay? If boat A accelerates at 0.6 meter per second squared, while boat B accelerates at 0.9 meter per second squared, determine the following at the instant when the two boats are 250 meter apart. Okay, this is quite tricky. Okay. I try to share one more time. I don't know, somehow I cannot share the content. Can you see my PDF file? Just checking with you. Kapil, can you see the PDF file?
No, sir.
No. Okay. How can I share the content? It's not working. Okay. You can see now? You can just extract this question. You can see the diagram, Kapil?
Yeah, see, sir.
Okay. Okay. What we should do, yeah. Okay, if you look at the question, okay, it tells you that both boats starting from here, from 0. Then it tells you, asks you to find, okay, basically you need to find the position of the boats when it is 240 meters apart. Just imagine, this is your starting point, this is your boat B, this is your boat, your boat A, this is your boat A, which is the angle between them is 75. Agree? 75 degrees. When both boats starting from O, they will move in that direction and that direction straight. And at some instances, they are 240 meters apart. 240. Okay? By knowing this distance, basically you know the position of boat B and boat E at this particular instant. Do you agree with me? Do you think we can get this OB and OA? Can we get it? Let's see, 75, this is 30, this is 45. Okay? Okay. So using some understanding of your sine rule, okay? Using the sine rule, you should get the distance of OA and okay, you need to find the distance of OA and OB. Why you need to find this? Because once you know the distance of OA and OB, then you can know the velocity at that particular instant. Yeah, just imagine, this is your boat A initially at O, and it moved to position OA. Okay, that is the distance of OA. It starts with, this is VA1 equals to 0. Here is VA2, and the acceleration is 0.6. Okay, this is the standard calculation, the normal calculation. Basically, you have your initial velocity, you have your final velocity, and you have the distance OA. So you can use the formula that which is VA2 squared equals to VA1 squared plus 2AA. The distance is the one that you get just now, OA. From here, you get your V at this instant. You need to find VA2, basically. Then you get your VB2. The same method, you get your VB2, which is here. Once you know the velocity of VA2, basically your VA2 will be certain value at an angle of 60 degrees. Your VB2, using the same method, you will get certain value with the angle of 45 degrees. Knowing these two, then you can use your relative velocity relative velocity analysis. Okay? This is asking you about velocity of boat A, velocity of boat B, velocity of B relative to A. So the velocity of VB relative to A is VB minus VA. This you know the magnitude and the direction as well, so you should get your VBA. Is it clear, Kapil? Is it clear, Kapil?
Sir,
You didn't get it.
how are we sure that 240 meter is horizontal and not like saying it ke apa ke?
So my understanding is 250 meter apart is horizontal. Okay?
Oh,
Okay. It should be horizontal, I think. Okay?
okay.
Okay, if it's not horizontal, then the calculation is definitely wrong. Okay, let's put it 240 meters apart horizontally. Okay, or else it's impossible to solve the problem.
Oh, okay.
Okay,
All right.
okay. Any more questions? I go back to. Okay. Okay, any other question? Let's see. Is there any question from the chat? From the chat, exercise 4.14, 9.14 from textbook, 9.14. Okay. 4.18, 4.14, 9.14. 4.18. Okay, let's see 4.18. I just briefly explained to you this 4.98. Okay, 4.18 before we go to 9 point, the one asked by your friend. Okay, 4.18. Okay, why I'm going to explain you briefly what you should know. Okay, you are given, the figure shows a boy playing kite on a flat field. If the boy runs straight with constant velocity 2.5 meter per second, that's the velocity of the boy. With the string r equals to 5 meters per constant and theta increasing at the rate of 2 degree per second, determine the velocity of the kite for the instant. Okay, what you should get is that you are given the theta dot. This is your theta dot. Your theta dot is 2, you need to convert this degree into radian, okay? 2 degree per second. How to convert 2 degree per second? You need to convert it into radian. You need to convert it into radian per second. Okay, that's what you do. Okay, knowing that theta dot and r, you can do some r theta analysis. Okay, how you to do r theta analysis? R theta analysis, you need to have a fixed point. What you should do, just fix this point, make it fixed. Okay, although this is not fixed because the boy is running at 2 meters per second, just make it fixed. If you fix this point, basically this will be your r axis, this will be your theta, axis. This is the positive theta, this is your positive r. Okay, so when doing your r theta axis, basically you can get your VR and V theta, where your VR is r dot, your V theta is r theta dot. What is your r dot? You are given your r is 5 meter per second constant. Means that your r is constant. If your r is constant, means that your r dot equals to 0. Okay, this is 0. Okay, your r theta dot, you get from here. R is 5. Your r is 5. Your theta dot is what you calculate here in radian per second. Okay. From here, you know that your velocity basically, okay, is your v theta because your VR is 0. So what is this v theta? This v theta is over here. This is your v theta, following the theta axis. This is your v equals to v theta, since your VR equals to 0. What is the v theta, or this v? The v that you get here is not the velocity of the kite, but this is the velocity of the kite as observed from B, or the boy. Okay? What you get here is V kite relative to the boy. Okay, so you know your Vk relative to B, you know the magnitude, you know the direction, you know the velocity of the boy, which is 2.5 horizontal. Then from there you can get the velocity of your kite. Is it clear? Is it clear? Who is asking just now 4.14? Farhan, is it clear?
Clear, Doctor?
Okay. Which one you asked me just now? Kapil? Kapil, which question, Kapil?
That didn't ask.
Who asked me just 9 point? 9.14, is it? Suga, is it? 9.14. Okay, 9.14. Okay, a rod bent into shape which comprises of a straight and semicircular part as shown. If the mass of the rod is 0.9, determine the mass moment of inertia of the x about x, I as x. The center of gravity of the semicircular part is at G, which is 2a over pi. Okay, remember in this problem, this is about the rod. You need to divide this into two components. Okay, the first component probably is this rod. This is your first component, the straight rod. The length is 2d, and your second component is the semicircular rod. This is not a disc, this is a rod. Okay, remember this is a rod. Okay, so we have two components. One is 2d, the length of the rod, and the second one is the semicircular ring. Okay, remember in your table you have disc, you have ring. So the solution for this, the semicircular ring, is the same as the example of semicircular disc. Okay, in your table you are given, okay, the formula for this axis. Okay, this doesn't pass through G. The only axis that pass through G is this axis. Okay, the other two axes does not pass through G. So if you look at the axis that you want to find, which is I as x is there. Okay, parallel axis to I as x is the one that pass through G, is this line. Okay, it's this line. Oh. Okay, this is the axis that pass through G, which is parallel to this axis on your in your book. Your G is somewhere here.